Hi everyone. It's been a while since my last upload, but I'm really glad and excited to be back. So today we're going to talk about chemistry. So this topic, electrochemistry, and I know that a lot of students are struggling and also confused how to discharge the ion. So I'm going to guide you all step by step about the factors, like which factors and how can we use it to discharge the ions. So before we start, I have a very exciting good news. So we now have weekly Zoom lessons. So if you like to learn with me, if you want to ask some questions and also to revise chemistry, so welcome you to join us and we will provide notes and also worksheets so you can revise more effectively. So let's start our lessons today. So we can see that the factors that affect the electrolysis of an aqueous solution. In total, we have three factors. So the first one, it will be the position of ions in the electrochemistry. So this series, it will be good if you can remember everything. But I know that a lot of students, they couldn't remember well. So what can we do? If let's say you can only remember a few, so you can choose the one at the bottom, which is from hydrogen, copper, and silver, which is argentum. For anion, you can remember this hydroxide at the bottom. But if you can remember everything, it'll be the best. But if you can only remember a few, then you can just try to remember this one, hydrogen, copper, and argentum, which is silver. For the anion, hydroxide. So what is this? The lower the position of the ion, the easier the ion will be discharged. So for this one, happen on the cations all the time. So no matter how, for cations, we will always choose the one at the bottom, which is hydrogen, copper, silver. Okay, so if let's say now you have copper 2 chloride solution, so if they say this is aqueous solution, so meaning you have water inside, right? So for the cation, we have copper 2 plus, and since it's aqueous solution, we have H2O. So for H2O, it will split into hydrogen plus and hydroxide ion. So we have hydrogen plus. So now we have two options. And which ions that you have to discharge. You have to look at the one at the bottom, which is copper, because copper is below hydrogen. So you have to discharge copper 2 plus. Okay, so this happens for the cations every time. So every time you look at the one at the lower position. So for anions, if everything is normal, if there's no special condition, we will also choose the one at the bottom. So since this is aqueous solution, it has H2O in it, so we will always choose hydroxide. If everything is normal, if there is no other factors, then we will choose the one at the bottom. Okay, so this will be the first factor. And now we look at this one. So just now we talk about aqueous solution, which is H2O, and we know that it splits into hydrogen plus and hydroxide ion. So I know that students always forget how to write the half equation for hydroxide, and this is the one. Okay, so it'll be 4 hydroxide produces 2 water, 1 oxygen, and 4 electron, where this is the half equation if we discharge hydrogen plus ion. Okay, so this will be the first factor. And now we move on to the next one. Let's see this example. Electrolysis of aqueous sodium sulfate solution. You can see there's a word solution, aqueous solution, meaning it contains water. So with carbon as the electrode. So everything is normal now. So we look at cations. So for cations, so some students, they are confused. Cations and anions, which one is a plus, which one is a minus. You can try to look at the word in the middle, right? In front of the ions. You can try to look at the letter which is in front of the ion. So this is a T. T looks like a plus, right? So it is a positive charge. And in front of the ion is an N. So this is a negative charge. Okay? So now we look at the cations, which is positive charge. We have sodium Na plus. And because of aqueous solution, we have H2O, which is H plus. For the anions, we have SO4, sulfate. And because of water, we have hydroxide. So please remember, we will never discharge sulfate as our ion. Okay, so let's see. Sodium and hydrogen. We know that hydrogen is at the bottom, so we have to discharge hydrogen plus ion. And for anion, we have to discharge hydroxide ion because it's at the bottom, right? So now we look at a half equation at cathode. So for half equation at cathode, it will be hydrogen plus electron. And when they turn into gas, it's a covalent compound, right? So they will turn into H2. So now we have to balance the whole thing. So 2 hydrogen, 2 electron. How about anode? So anode, remember, it will be 4 hydroxide, produces 2 water, 1 oxygen, and 4 electron. That's the half equation if you discharge hydrogen plus and hydroxide ion. Okay, so now we move on to the next page. So the next factor will be the concentration of solution, where this only affect the anions. So concentration. They always mention concentrated halide ion. If they mention concentrated halide ions, then we have to discharge halide ions because they have higher concentration in the electrolytes. So we will ignore the one at the bottom because now they are so concentrated that we have to choose them. So this happened for the halide ions. And which one they are the halide ions? In the series, we have fluoride ions, we have chloride, bromide, and iodide. So all these, they are the halide ions. So for example, if we have concentrated hydrochloric acid, so we have chloride ions, and because it's acid, it has H2O in it, so it has hydroxide. So which one we have to discharge now? Because this is so concentrated, we have to discharge chloride instead of hydroxide. So remember, this only happens at the anode for the anions. How about the cations? It is still the same. Always choose the one at the bottom. So now we look at the example. The first case, we have aqueous copper 2 chloride solution. And this is the first one, concentrated. So the first case is concentrated copper 2 chloride solution with carbon as the electrode. So now for the cations, it will be copper 2 plus. Because of the solution, it has H plus. For the anions, we have chloride ions. And also the solution H2O, we have hydroxide. So now which one we have to discharge? So look at cations. We have to discharge copper because it's at the bottom. It's below hydrogen plus. For the anions, because of the word concentrated, we have to discharge chloride because it is so concentrated that we need to discharge chloride ions. Okay, so let's see the half equation at the cathode. So we'll start from copper 2 plus ion. To balance this 2 plus, we have to put electron here, which is 2 electron, and they become copper. Okay, how about at the anode? So at the anode, we have chloride and chlorine gas. Also, they will form covalent bond where they form Cl2 plus 2 electron. because two chloride ion. Okay, so that's the case for concentrated. How about dilute? If it's dilute, meaning it is not concentrate anymore, right? If it's not concentrate anymore, then let's write the cations again. We have copper 2 plus, we have H plus, anions, we have chloride ions, we have hydroxide. So now since it's dilute, it's not that concentrate anymore, we will choose the one at the bottom. So which is copper 2 plus and hydroxide ions. Okay, so now let's see the half equation at cathode. It is still the same. And for the anode, it will be 4 hydroxide, produces 2 water, 1 oxygen, and 4 electron. So the third factor will be the type of electrode. So, and again, this will affect the anode only. So when we are using active electrode, for example, copper and silver as the electrode, so we will look at the anode now. No anions are discharged. So if there's no anion, so what happened? We will only choose the metal itself. We will only choose the metal itself, and the metal itself will release electrons and they form metal ions. And again, this only happens at the anode. How about cathode? It is still the same. Choose the one at the bottom. So now we look at this example. Electrolysis of aqueous copper 2 sulfate solution with carbon electrode. So carbon electrode, carbon and platinum, they are inert electrodes. So let's see for the cations, we have copper 2 plus, and also because of H2O, we have H plus. For anions, we have sulfate ions, and also we have solution, so we have hydroxide. So now, cations, always choose the one at the bottom. So meaning we have to discharge copper 2 plus. So Cu 2 plus, they turn into Cu. How about anode now? This is carbon as the electrode. So we are going to discharge hydroxide ion because it's carbon as the electrode, which is inert. So we are going to discharge hydroxide. So it will be 4 hydroxide produces 2 water, 1 oxygen, and 4 electron. Okay, so now we look at the second case. If it's copper as the electrode, this will affect the anode. So now we also need to try to write down all the cations. It's the same thing. Cu2 plus, H plus, sulfate, and hydroxide. So now for the cathode, it is the same thing. So we're gonna discharge copper 2 plus. So which is Cu2 plus 2 electron becomes Cu. How about anode now? So if we are using copper as the electrode, we will ignore all the anions. We will only choose the electrode itself. So initially it is a metal, so it will start with no charge, Cu. And it will actually release electron, so become Cu2 plus 2 electron. So what do you see now for this case? We can see at the cathode, a lot of copper 2 plus, they are discharged and become copper atom, the metal itself. And at the anode, it's just another way around. So for this case, for the electrolyte, the amount of copper 2 plus inside still remain the same. So meaning at the end, the blue intensity of the solution remains the same. So let's look at the summary now. So we learned 3 factors in total. So the first one, it will be the position. So first will be the position, and the lower it is, the easier to be discharged. And this always happen for the cations. right? We have to remember the one H plus, Cu2 plus, Ag plus. Okay. And how about the anions? So also it will affect the anions, but given everything is normal, and we will always discharge hydroxide if everything is normal. Okay, and now we look at the next one, which is concentration. So for concentration, this only affect the halide ions where they are the anions. So halide ions, it's either fluoride, bromide, or iodide. So all this, they will affect the anions only. So meaning we will no longer discharge hydroxide. Okay, it's just about, and this is just for the anions. And the last one, which is E. So E stands for electrode. And what kind of electrode? It must be the active electrode where we refer to copper and silver. And this one, it will affect the anode only. So meaning we will ignore all the anions. So we will ignore all the anions and we will only look at the anode itself. So if it's copper, it will become copper 2 plus 2 electron. If it's silver, it'll become like this. Okay? So I hope you can understand better now. So in total, we have only three factors. And the first one, precision, the second, concentration, and the third one is the electrode. So if you would like to join our weekly lessons, you can always let me know. You can either PM here or you can just find me through Instagram. Okay, so I hope you can have a better understanding now, and I can't wait to see you next time with more exciting topics. So see you and have a nice day. Bye.